Hello, my name is Eric Chappell, author of AutoCAD Civil 3D 2013 Essentials, and this is the additional exercise for Chapter 17. This is a really great exercise because here we're going to see the power of Civil 3D really come together. We have designed alignments and profiles and corridors. We have laid out lots and we've created grading along those lots. We've even graded ponds and really have a complete model of our design. Even the pipes have been created, and all of this has been linked together into one smart model that Civil 3D has been tracking and managing all along. And now that we have all of this in place, we're going to take a look at the earthwork balance of the project. And actually, in reality, we would have done this a long time ago. And as you're going to see in a moment, we're pretty far out of balance. So let me just show you that. I'm going to create a 10 volume surface using the volumes dashboard, and I'm going to call it volume check. And for the style, I don't need to see this surface. I'm just interested in its analysis data. Base surface will be EG, and comparison surface will be FG final. Now I do want to point out that a complete and thorough earthwork analysis is more detailed than just EG versus FG, and if you're not an experienced designer, you will learn that eventually. But you have to take into account the depth of pavement, you have to take into account topsoil, you have to take into account unsuitable material in the project. I don't want to oversimplify the process that goes into doing what we're about to do, but in the interest of time and learning the material, we are going to do an EG to FG comparison. So I'll OK that, and after it crunches the numbers, we see that we're way in the fill side. You can see the graph shows a lot of green, and we're 76,000 yards in fill. Alright, so as it is right now, if we were to build this project right now, we would have to have 76,000 cubic yards of material brought in from a borrow site. And that's going to be really expensive and not something that we want to do. So our job as designers is to get this balanced out, and that's one of our most important jobs, because balancing that earthwork is really going to reduce the cost for the project. It's going to reduce the environmental impact as well, which is really important. So I'm going to close down my volumes dashboard, and let's think about what we have built here. We've drawn alignments and profiles and built corridors off of those. So a really quick way that I can get less fill and more cut out of this project is if I push the profiles down, it's also going to push the corridors down. So I see right away when I look at the Jordan Court profile that here's my design, and there's a good bit of it above the existing profile here, and that's generating a lot of fill. So right off the bat, I'm going to grab this profile and pull it down. And what's going to happen is my corridor is set to rebuild automatic. It's going to rebuild automatically. It's one of the surfaces that contributes to my FG final surface, so that's going to trigger an update of that surface, and everything pretty much drops down from here to down here somewhere. So we just severely drop this road. In fact, if we look at the side slopes, we can really see that drop here. Alright, and if we look at the lot lines, we can see that there's some very steep slopes in front of these lots that, because the building pads are not dynamic. Those stayed right where we put them, while the road has been dropped down significantly. Okay, so we look a little further, we see another opportunity to drop that profile down here on Madison Lane. So the bottom 2/3 of Madison Lane is being dropped down. Now if you take a look at the pipes, you'll notice that the tops of the structures drop down, but the pipes don't. We would have to eventually go in and get the pipes adjusted, but the structures have been adjusted. So we were at 76,000 cubic yards of fill. Let's see where we're at now. I'm going to click the volumes dashboard. It tells me I'm out of date, so I'll rebuild it here. And now we're at 61,000. So that's a pretty good drop, but we still have a long way to go. Well, let's not forget, we also have some of these building pads that They stayed up high while we dropped the road down. So to get a sense of where those areas are, where are these slopes really steep, we'll use a trick that we learned a few earlier in the chapter. We're going to use a surface style that tells us a story about the slope. So I'm going to change my surface style to slope banding 2D. And now all of a sudden we start to see all these red and orange areas that are steeper than they should be. So I'm going to use display order to send that to the back. And I'm going to pick the building pads that have the orange or red in the front, indicating that these front yards are too steep for driveways. Okay, and they're right where I'd expect them to be, along the lowered portions of Jordan Court and Madison Lane. Alright, so what I can do now with those selected, I can use my feature line tools, right click and say raise lower, and I'm going to drop them down 2 feet, -2. Again, everything's set to rebuild automatic, so it's all going to update automatically, and we should see these colors change. And it looks like we didn't quite lower them enough. There's still a little bit of orange there, or unless I went too far, and maybe it should have been 1 foot, but let's just hope that I need to go a little further down. So I'm going to grab some of these that still have orange in the front yard and lower them down a little more. So let's go another foot. Alright, so I'm getting a little better each time. So now if I check my volumes dashboard, I think it's 61, and now I'm down to 52. So with each change, I'm getting closer and closer to a balance. So maybe I'll try another change. Maybe we can make this low point here a bit lower to really force, drainage down into that low point, but also create some additional cut for our project. Right now the corridor is rebuilding, and that was that pause that we saw. And maybe we can lower Logan Court a little bit. Of course, we've got intersections going on there, so that's already been taken care of for us. But what are some other areas that we can cut down a little bit? Here we're a little above existing ground, so let's drop this down a bit. And this is what design is all about. It's going in and making decisions about where to make changes based on your experience as a designer and your knowledge of the technical aspects of it. And let's see what that did for our volumes. I think we were at 52 before, now we're down to 46. Still got a good ways to go, but if we look at our orange and red here, we've got a fair amount of that to address as well. So as we continue to lower these building pads down and make some of the orange and red go away, we're also going to be improving our earthwork numbers at the same time. Our end goal is to get it to as close to 0 as we can, but we'll never get it perfectly. Now, another part of this exercise is to do some labeling, so we want to take care of that next. So the idea here may be that it's part of our local requirements to show the driveways, the front yard slopes, because maybe in this county or in this particular community they want to keep the slopes of the front yards between, say, 5 and 1% to make nice flat front yards. So you can see we've already created some labels for the first few lots, and we can actually just copy these labels to the other lots. We don't even need to use the add labels command. We can copy them, and this is going to tell us where we've got issues. It's also going to tell our reviewers where we've got issues, and of course if our maximum slope in the front yard is 5%, we're going to need to address some of these before we turn it in. Or we could say, what, we're actually planning on putting our driveway over here. Let's say our maximum slope is 10%. There we're at 7.7, so we can say to the county or whatever the review agency is, this is where our driveway is going to be in this area. Same thing here. Now in this area we've got some problems, so we're going to need to lower this building pad down, and I can use my raise lower command and maybe drop it down a foot. That should give me some more green area. I can move this label out here and show the review agency that we've got adequate flat area in the front yard. We'll do the same thing for this building pad. So you can see that the labels are not only just a good annotation tool, they're a good design tool as well. Now if we needed to create the labels from scratch, we didn't have other ones to copy from, we can just use the add labels command and say we're labeling a surface, slope, percent. I'll click the add button, pick my surface, and I'd like to do a 1-point label because I want it to point in the downhill direction. And that's all there is to it. So the slope label requirement for that exercise is pretty simple. So we've adjusted the road profiles, which has rebuilt the corridor automatically. We've changed the surface style so that we can see the slope colors to see where the steep slopes are. We've created labels to indicate with some text what those slopes are. And then we've also taken into account the fact that we're going to need to adjust the building pads after adjusting the road elevations so that they kind of match the change as well. So with all those things taken into account, and we've begun to address them. Of course, when you do this exercise on your own, try to get it as close to balance as you can. As you can see, it's an iterative process. You're going to drop the road down in certain areas, then you're going to need to drop the building pads down in the same areas until you finally get that design as close to a balance as you can. And the tool that you use to check that is the volumes dashboard. And you can see just how easy it is to keep track of your volumes as you work. I'm down to 45,000 fill, getting better and better with each design change that I make. So that takes care of the additional exercise for Chapter 17.